Hey guys, welcome or welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with the 7th video for my AIME series. Today's video comes from the year 2020 and it's problem number 7. I hope you guys enjoyed this video and let's get started. The problem states, a club consisting of 11 men and 12 women needs to choose a committee from among its members so that the number of women on the committee is one more than the number of men on the committee. The committee could have as few as one member or as many as 23 members. Let n be the number of such committees that can be formed. Find the sum of the prime numbers that divide n. So first we have to recognize that if these two represent, this would be the women and this would be the men, and these smaller circles are the chosen ones, I'm going to let the number of women that are chosen be k. So that means that the number of men chosen would be k minus 1. So we know that k and k minus 1, this forms a committee. And we're trying to find the number of these combinations. But we also must recognize that taking the number of women chosen and the number of men not chosen, so it would be k, the number of women chosen, and then we're just going to first choose 12 people. It doesn't have to be all women, just 12 people from the total of 23. That means that if, again, the number of women chosen out of the 12 are k, that means that the number of men would be 12 minus k. However, 12 minus k is not the number of men chosen because 12 minus k does not always mean that it is going to be one less than the number of women. So keep in mind that k and 12 minus k, it does not form a committee. But for every committee that is formed, there's always one committee that cannot be formed, which is k and 12 minus k. So that means that as we've chosen 12, the total of 23 members, if we choose 12, then that is the committees that cannot be formed. However, as just stated, that the committees that cannot be formed correspond to the number of committees that can be formed. So technically, finding the number of combinations of choosing 12 from the 23 is the same thing as finding the number of committees that can be formed. So we are going to figure this out, which this is in. So it would be 23 factorial over 12 factorial, and then 23 minus 12, so 11 factorial. And now we can just write all of this out, and it'll cancel. So 23 times 20. And I'm going to stop at 13 because the rest will cancel out with the 12 factorial. So what we're left with on the denominator will just be 11 factorial. And now we can cancel some of these numbers out. Okay, so after canceling out the numerator and denominators, we get 23 times 19 times 17 times 13 times 7 times 2. And so these are all the prime numbers from n. So all we have to do is add this up. So our answer is 81.